Hi everyone! Today is Wednesday, April 19. So we are one lecture behind. So that's why I decided to move your quiz 6 to Monday. It was supposed to be on Friday, so I moved quiz 6 to Monday. Okay, so today we'll finish 5.4, and then this Friday, the homework 5.2 and 5.3 is due. And then on Friday, we will talk about 5.5. And then on Monday, you can, so over the weekend, you can work on the 5.4 and 5.5. And then also your quiz 6 will base on 5.2 to 5.4, mainly 5.4, which we're going to learn today. And then exam is on the Friday. Okay, so we're very, very busy. And yeah, we have no choice because we need to cover all the course objectives, right? So before the final. Okay, the practice exams is already posted on the website. So you work on it over this weekend using pencil. After you finish, use red pen to check your work. And also the video session recording. Okay, so at the bottom here. So today I give you the useful formula for exam 3. Okay, and then yeah, after we finish this chapter, we'll go over together. And then this is the video session recordings. And yeah, I give you my available hours this week and next week. You can put down your time. So you watch the recording when you're done. Don't watch it the last day before the exam. Promise me you watch it earlier, okay? So when you have questions, you can still ask me. Okay, everybody? All right. So that is our plan. Let's look at our quiz 5. Okay. So this is the solution. First step, we factor the numerator and denominator. The numerator, we can factor as x minus 3 and x minus 2. The denominator is a linear term, so we cannot factor further. To find the x-intercept, we set the numerator equal to 0. So numerator, x minus 3, x minus 2 is 0. Solve for x. So x minus 3 is 0, or x minus 2 is 0. So we get x equals to 3 or x equals to 2. X-intercepts, they are points. So give me ordered pair, 3, 0, 2, 0. And then y-intercepts, we evaluate f of 0. So we plug in x as 0. Therefore, you plug in the original form. Okay, so you have two forms. You have the original form and you have the factor form. So you plug in the original form, then you get, all the terms with x are gone because x is 0. So we get 6 over 4, which is 3 halves. So the y-intercept is 0, 3 halves. And then next, to find vertical asymptotes, you set the denominator not equal to 0, okay, to find the domain. So therefore, we get 7x plus 4 is not 0, 7x is not minus 4, so x is not negative 4 over 7. And many of you forget to show this work. So please pay attention in the details, okay? How I show you in class in the examples. So sometimes only getting the conclusion is not enough. You need to show all your work. So many of you forget to check. When x goes to negative 4, 7 from the right, what happened? And when you plug in the x goes to negative 4 over 7, that corresponds to this factor, 7x plus 4. We'll go to 0 plus, okay? So, and you plug in the factor form. Don't plug in the original form. Is that clear, everybody? Plug in the factor form. Everybody say, factor form. Factor form. So, that's why you plug in here, yeah? Negative 4 over 7 minus 3. Negative 4 over 7 minus 2. and then your denominator goes to 0 plus. That's why you have negative number times negative number over 0 plus. You get 2 negative, give us positive. So we get positive infinity. And then on the other hand, when x goes to minus 4 over 7 from the left, the y will go to, you see, the only difference is the 0 plus change to 0 minus. That's why we gain 1 negative sign. So the answer is minus infinity. So this is 2 points. Show all your work in order to receive credits. And then for horizontal asymptote, you cannot just say none. Why? You have to explain why. So the steps are find the dominant term of numerator. The dominant term of the numerator. Which one has the highest power of the numerator? The x squared has the highest power. So the dominant term is x squared. How about the dominant term of the denominator? 7x. That's why you write down dominant term of numerator is x squared. Dominant term of denominator is 7x. So when x goes to infinity, y behave like we just look at the dominant term. Do you see the x and one of the x here cancel? So you have x over 7. If x goes to infinity, infinity over a number is infinity. Is that clear, everybody? And when x goes to minus infinity, your x goes to minus infinity over a number is minus infinity. So you need to show this word is 1 point. Okay, finally, use all those information. We have x-intercepts 2 and 3. We have y-intercepts 3½ here. And then this is the vertical asymptote. Put dash line and label. Please label the number, okay? And negative 7,4. And see here, when x goes to this number from the right, the y goes to infinity. So that means the right side and top. Yes, everybody? So you draw a little dot here. And then when x goes to this number from the left. Okay, everybody look at me. This is very, very important. I hope you can do well on your exam. So this is from the left. And the y goes to minus infinity, which is the bottom. You see that dot? And then we don't have horizontal asymptote. Okay, when y goes to x goes to infinity, y goes to infinity, so this side. And then when x goes to minus infinity, y goes to minus infinity, so down. Therefore, you connect all the together, and then this dot, this dot, this dot, this dot, and go up. And then this dot, and go down. Okay, everybody? So this is how we graph rational functions. Okay, so let's look at the mistakes. All right. So this is the C's. So what's your recording for the thing series? Were you here? Is it 5.2? Is the old worksheets? Yeah. Okay. Okay. So here, this missing the x-intercepts. So each part has points. So x-intercept is 3 points. The y-intercept is an order pair. It's a point. So 0, 3½. And when you plug in, so when you let x go to minus 4 over 7 from left or right, you plug in the factor form. Everybody say factor form. Okay. And then here, when x goes to infinity or minus infinity, you look at dominant term of numerator, dominant term of denominator. Is that clear, everybody? So, and that is why we don't have horizontal asymptote. So x is not the curve is not approaching to a number. It goes up. Okay? And then here it goes down. It goes to infinity and minus infinity. Okay, and then here, see, y, you have to show x goes to the point from the left or right, and what happened to your y. And then here, y, we don't have horizontal asymptote, so you have to show all your work. Okay, and that's why here it goes down and go up. Okay. So yeah, many of you have this mistake. So before you do the quiz, did you look at your class notes and review the class notes? Little bit. But then you can see in the class note how many steps I showed, right? So in the quiz and the exam, you have to show all those steps. Otherwise, you lose points. Okay. So I hope that you can get as many points as you can. I don't want that you know the material, but you lose points because you didn't write enough. Okay? So please, I want you to understand the requirements, and then you can show all your work and receive all the points. Okay, everybody? All right. So yeah, similar. Here you plug in the factor form to find vertical asymptote. You plug in the factor form. To find horizontal asymptote, you look at the dominant terms of numerator and denominator. Okay. So yeah, so I think many of you have similar mistakes, right? You didn't show the all the work. That's why you lose points. Yeah. Oh, here. Yes, x squared over 7x. That's not 0. You cancel the x, you get x over 7. And the x goes to infinity. Your numerator goes to infinity over, okay, so infinity over a constant is infinity. Okay, everybody? And constant over infinity is 0. Constant over infinity. Think about 7 over a big number. You get 0.00007, right? So that's why a constant over infinity is going to be a very small number, so 0. Okay, everybody? And then here, yes, dominant term of numerator and denominator. And here, yeah, figure out what happened. X-intercept and Y-intercept, they are points. Okay. And yeah, similar mistake. Okay, and yeah, so similar mistake, missing those details. Okay, so you see, you're not alone. Many of you didn't show enough work. Okay, so clear about the requirement now? Yes, raise your hand. Okay, good. So let's continue. Okay, so that is your quiz. And let's continue with session 5.4. So it's the same handout as last time. So last time we talked about the law properties, and those rules were what? Log break the products into sum outside the log, right? And log break the quotient into subtraction outside the log. And when you see n in the exponents, you can move the n down in front. Yes, everybody? And then we also have the change base formula, log ax. If you want to change to any base, usually we use the natural log base e. So that's ln of x. See, x is above a, so you put x above, a below. This is how I remember. Thank you. And don't forget that sheet, you sign the time and your name that you want to meet. Where is that sheet? Oh, okay. Yeah. Oh, right. Okay, so let's keep going. Exponential and log equations. So we call that when an unknown is in the exponent, we want to solve the equation by rewriting it in the log form. Okay, thank you. Okay, so log and exponential function, they are inverse function. Inverse function. So that means Well, you have log b to the x, you get x back, right? So log b and b cancel. And b to the log b of x, you also get x back. So this is what it means by inverse function. Okay? And then now, when you see equation involving exponential function, what you do is isolate the exponential term. So isolate means you only want to have that exponential term on one side by itself. All the other stuff move to the other side. So here, we want to get rid of the 2 and get rid of the 1. What do we do? Divide it by 2 first or subtract 1 first? So subtract 1. We get 2e to the 12x equals what? 17, right? Then what do we do? How about you guys take turns to answer my questions? Derica, what do we do next? Yes, divided by 2. So we get e to the 12x equals 17 over 2. Is that okay, everybody? We isolate the exponential term, right? Yes, we isolate the exponential term. Okay, now how do we carry out the exponential term? You know, exponential term and the log, they are inverse function. So we apply log on both sides. Okay, so we apply ln on both sides. So we get ln e to the 12x equals ln 17 over 2. Do you see ln and e, the inverse function, they cancel, right? So we get, what do we get? Quinton. ln and e cancel. So what's left? 12x equals ln of 17 over 2. What is x? So how do you solve for x? Subtract the 12? Or this is multiplication. So what do? Divide it, yeah. So ln of 17 over 2 divided by 12. Okay. Diana, do you have your calculator? No. Haley, do you have calculator? Everybody plug this in your calculator. Oh, your phone also works. You know your phone, you put it horizontal, it has the ln. Yeah. So what is the ln of 17 over 2? And then divided by 12. Everybody use your calculator. Oh, you get it?
No, I was asking a question about it. So,
Oh, sure.
so do I put it over to and not divide it?
Is it the same? Because I never used that function.
Because that would be
Okay. But divide by 2 also works. It's the same. I think divide by 2 is better. And then, oh, if you have parentheses here, you want to close parentheses and divide by 12. Do you get 0.178? Yes. Okay, 0.178. Okay. So solve for x. So 3 steps. Isolate the exponential term. Apply ln on both sides. And then solve for x. Okay. All right. And then in some cases, it's easier to take a log of both sides and then use the power rule. This is especially helpful when there are different bases in the same question. So here, this exponential function, the base is e. Do you see this example too? The base is 2 and 3 is not e, right, everybody? So in this case, you also apply ln, okay? So you also apply ln, even though you have a different base. So when you apply ln, you get ln of 2 to the x equals ln of 3 to the x plus 1. Okay, so you apply ln and on both sides. Okay, and then use the law property. Okay, the law property says we can move the exponents down in front. Is that okay, everybody? Do you remember the law property? Which is your previous page here. You see, you can move the end down in front. Yes, everybody? So that's why here we can move the x down in front. We get x times ln of 2. And then here we can move the x plus 1 down in front. You get x plus 1, but don't forget parentheses. Because when you move it down, it's the whole thing multiplied by ln of 3. Is that okay, everybody? When you move it down, it's become multiplication. And you need parentheses. Everybody say parentheses! Parentheses, yes. Because this is really a common mistake. When students move it down, they forget to include a parentheses, then it's going to be wrong. Okay? Now, what do? Is we want to solve for x, right? So that's why we want to distribute. Okay, so distribute. So we have x times ln of 2 equals x times ln of 3 plus 1 times ln of 3. 1 times ln of 3 is ln of 3. Is that okay, everybody? Alright, we want to solve for x. So you want to group all the x together. Yeah, put them on one hand side. So we want to move this to the left, right? Okay. So here we want to, bless you, move all the terms with x on left hand side. Move all the terms without x on the right hand side. Okay. It's not necessary left hand side. It's just one side you have terms with x, and the other side those are the terms without x. Okay, you put them in different sides. So here we subtract x times ln 3. And then on your left hand side, you see on your left hand side you get what? X ln 2 minus x ln 3. And then your right hand side, this cancel. You get ln of 3. Ln of 2 and ln of 3 is just a number. Okay, you treat it as a number. Okay, do you see on the left hand side, we can factor x? So we factor the x. So we get x times what? Ln 2 minus ln 3 equals ln 3, right? So therefore, your x equals ln 3 divided by ln2 minus ln3. Okay, so 6, solve for x. So divided by that factor. Okay. Let's see. Everybody put this in your calculator. What do you get? So you type ln3 divided by parentheses. ln2 minus ln3. Parentheses. Who else wants to meet me? So I will also bring it on Friday and Monday in case more of you want to see me, okay? What do you get? 3 decimal places. 0.95. Oh, sorry, round up to 10. Yes. Do you everybody get this one? Did you forget the parentheses somewhere? What did you type? ln of, oh, you see, you miss a parentheses here. It's ln of 2 close parentheses. And you? ln of 2. Oh, you miss a parentheses here. See a denominator? This is the whole thing is the denominator. So you need a parentheses here and here. Yeah, in front of the ln. Because otherwise, this is the denominator is like this part. And then you Mm-hmm. Yeah, so you just need one more parenthesis. Where was that? Okay. ln3 close parentheses divided by your denominator is 2 terms. So you need another parenthesis here. So you were missing this parenthesis. And then ln of 2 close parentheses and subtract ln of 3 close parentheses, one more parenthesis because this is the denominator. So okay, so everybody make sure you know how to use your calculator. Okay, so continue. We call exponential function is always positive. Exponential function. The graph look like that, right? It passed through 0, 1. And you see it's always positive. Therefore, find the exact solution of the following. Can you see a common factor? X and e to the x. So x, e to the x. After we factor, what do we get? Deanna, after we factor x and e to the x, what do we get? What's that? After we factor out this, what's that? Huh? Here. Oh, we factor out x. Yeah, 3, and then how about this term?
X squared.
Yeah, but you factor out x and e to the x. What's that? So x squared e to the x, but you factor out x and e to the x. Yeah, an x left. Right. So that equal to 0. And now we set each factor equal to 0, right? So we have x is 0, and e to the x is 0, and 3 plus x is 0. But you know e to the x is always positive, therefore you can rule out this case. Is that okay, everybody? It won't be 0. So we get x is 0, and then how about this? Haley, x equals to, yeah, -3. So that's why we have 2 solutions, 0 or -3.
So the EDS you can do
It's not possible.
it's not possible because it's only positive.
Exactly. Yes. Right, everybody? Okay.
Actually, yeah. Will we deal on the exam? Will we deal with examples where e of x equals something positive?
Yeah. Then you take ln. Then you take ln. Yes. Yes, good. Okay. Hidden quadratic. We've seen this before in chapter 1, right? Hidden quadratic. So you can see here, e to the 2x. E to the 2x is like e to the x squared. Do you agree, everybody? So this is a hidden quadratic. You use a substitution. So you let u be e to the x. And then when you plug in, you get u squared minus e to the x is u minus 6 equals 0. Is that okay, everybody? We recognize e to the 2x is e to the x squared. Now you have a quadratic like this is a square of that, right? So therefore, you let u be the smaller one, which is e to the x. And this is u squared minus u minus 6. This is a quadratic equation, right, everybody? It came out. How do you factor it? Minus 3 and plus 2. Yes. Good. So we set each factor equal to 0. What is u, Jason? 3 or -2, right? Okay. Now, what is u? U is e to the x. So we plug in. E to the x is 3 or e to the x is -2. Can e to the x be a negative number? No. So in this case, you can rule out. E to the x is always positive. Okay, how do you solve for x? Even.
Solve for x.
Yes. How do you
Oh,
get rid
yeah,
of?
you do natural log.
Yeah, we do natural log. So we get natural log e to the x is natural log of 3. Now and e cancel. So x is ln of 3. Right? And because the problem said approximate to the nearest thousand. So put that in your calculator. What do you get, Peter? 6. So we increase round. Yes. Everybody, if the next digit is greater or equal to 5, you round up. If the next digit is less than or equal to 4, you round off. Okay, everybody? Okay, good. So that is about equation involving exponential function. Okay? And you can isolate the exponential function and then apply log. Okay, now let's look at equation involving log. Okay, if you see equations involving a log expression, isolate the log. Okay? Isolate the log term. And then apply, to get rid of the log, you apply exponential function on both sides. So here, what is the log term? Log 4 of 2x. This is the log term, right, everybody? We want to isolate it, so which means I don't want to see the 4 here, I don't want to see the 3 here. What do you do? Subtract 4. So we get 3 log 4 of 2x. David, what's 16 minus 4? Wow. Can you also tell me what do we do next?
Divided by 3.
Divided by 3. Okay. Oh, if you missed something, don't forget to watch the lecture video. Okay. Can you also tell me what's 12 over 3? 4. Oh, we get log 4 of 2x equals 4. Okay. See, here, this is log base 4. If we want to get rid of log 4, okay, remember, inverse function log b to the x is x, b to the log b of x is also x. So if you want to get rid of log 4, you need to apply what? 4 to the exponential function base 4 on both sides. Okay, so in this case, it's 4 to the something on both sides. So we got 4 to, maybe let me do it in the next step. So 4 to the log 4 to x is 4 to the 4. Is that okay, everybody? We apply both sides, exponential function, base 4. Analysis. 4 to the log 4 2x equals 2x, right? Because they are inverse function, they can cancel. Do you know what is 4 to the 4th? Use your calculator. 256, thank you. Okay, how do we solve x? We divide it by 2, and what do you get? Alice? 128. Yes. Okay, everybody? So when you see exponential term, isolate the exponential term and apply log. So when you see log term, isolate the log term and apply exponential. Because they are English. Okay? You can apply those to carry on. Okay. So this is example 5. Some cases, so you can see here, we only have a single log term. That's why we can isolate it. But sometimes, if you have more than one log expression, then what do? You need to condense into a single log. That's why our last class is so important. Remember our last class? When you have more log expression, you can combine into a single log, right? And if you have a single log, you can expand it to a simple log expression, right? That's why we can use those here. Okay, so condense first when you have more than one log expressions. Okay, so like this problem, you want to combine into a single log. And when you see sum, you combine into what? Sum, you combine into product or the quotient? Products. When you see subtraction, you combine into quotient. Okay, everybody? So log, okay, log P plus log Q, you combine, you get product. Log P minus log Q, you combine them, you get division. Is that okay, everybody? By the way, if you don't see any base, that means, what's the base? 10. 10, 10. If you see Ln, the base is E. Okay. So therefore here, we combine into a single log. So we get log into product. So product, x plus 2 times x minus 1 equals 1. Is that okay, everybody? And now, you see, second step, isolate the log term. And so whatever we continue, it's going to be similar to the previous problem. And in this case, it's already isolated, right, everybody? So how do you get rid of log base 10? You apply exponential function base, what? 10. Apply 10 to the something. So 10 to the log of x plus 2 times x minus 1 equals 10 to the 1. Is that okay, everybody? You want to get rid of the log? Apply exponential function. And the base is 10. So apply 10 to the power of it. Okay, 10 and log cancel, right? So the left-hand side, you get x plus 2 times x minus 1. The right-hand side, 10 to the 1 is 10. Okay, now, do you see you get a quadratic equation, right? So how do you solve quadratic equation? Because the right-hand side is not 0, you cannot set both factors equal to 0. You have to distribute, move all the terms to one-hand side, and then either factor or use quadratic formula. Okay, everybody? So, yeah, so let's keep going. Okay, so distribute. Kayla, when we distribute, what do we get? So, oh, okay. So, sorry, my word is not responding. Hey, something wrong. Oh, is it because no battery? Okay, let me try. Oh, x squared and then what? Plus x. Oh, x squared. You mean minus x? Oh, you already. Oh, you already added 2x already. Okay. And then what's next? Yes. Is everybody okay with that? Because you subtract x and then you add 2x. That's why you get positive x. Yeah? Equals 10. What do we do next, Cohen? Yes. Yes. Can you factor it? Let's see. Cora, can you factor it? Minus 12. What are the factors of minus 12? 6 and 2. Or 6 and 2, the difference is 4. It will give us 1, right? So 4 and 3. Which one is negative? The 3 is negative. Yes. So we have x plus 4 and x minus 3. Is that okay, everybody? Okay, awesome. You see, the product of two factors is 0. We can set each factor is 0. Okay? At this step, because the right-hand side is not 0, we cannot set each factor equal to 0 or 10. We cannot do that. We have to make sure the right-hand side is 0. Then we can set each factor equal to 0. Okay, what is x? Negative 4 or what? Positive 3. Okay. Now, when you solve for x, okay, so 4, we solve for x, okay, and then 5, you need to check the domain, okay. So, because when we have exponential function, okay, when we have equation, we call it exponential function. Because for exponential function, the domain is all real numbers, so you don't need to check the domain. But for log, the domain is only positive numbers. That's why when you deal with problems with log, you need to check the domain. Okay, so yeah, last time we forgot to check the domain, so let's check the domain. So that means, look at your log expression. You get log for 2x. X is 128. Do you see? It's okay. You have positive number inside the log. That's okay. Yes, everybody? So check domain, it just means you plug your x back here to the log expression to see if that thing inside the log is positive. Okay, so now here, check domain. Let's check the -4. If you plug in -4, you get log -4 plus 2. Is that okay? -4 plus 2 is what? -2. So when you have negative number inside the log, that's not okay. That's not in the domain. So no. Oops. Sorry. I don't mean to erase. So therefore, not okay. So this is not a root. How about x equals to 3? You plug in log 3 plus 2. Is that okay? Yes. And log 3 minus 1. Is that okay? Yes. So this is the solution. Okay? So you check all the log terms. If one of the terms is negative, the thing inside is negative, then it's not okay. You don't have to check all. One of them is not okay, then it's not okay. And then yes, and then if it's okay for one, you have to check for all. Then it's okay. Then this is the solution. Any questions? All good? Okay, have a nice day.
We check the name for all of these, like
No, exponential function, don't need to check. His domain for exponential function is all real numbers.
Okay,
It's the log.
the log.
Yeah, remember the function with the domain, they are the square roots, the fractions, and the log. That's why when you solve equations involving square roots, fractions, and the log, you need to check the domain.
Okay.
Yeah.
Okay.
Hi.
Good morning.
Good morning.